Hi everyone. We have one lesson left to do with our rational functions. This is on solving equations with rational functions. And when I say solving equations, what I mean is we're going to be solving for x. So notice these look a lot like the problems you did yesterday, except now they have equal signs on them. And that's what's going to allow me to solve for this missing x value. Now, when I solve this, I'm going to use a technique called clearing the fractions. And I teach this technique early on in Algebra 1, okay? And I talk about how this is a really good strategy to learn and this is a really good technique and it cancels out your fractions. That's why it's called clearing the fractions. It makes it so that you don't have fractions in your problem anymore. And a lot of my students are like, no thanks, I'd rather just do common denominators and stick with the fractions. I feel comfortable with that. And I totally get that. But with these fractions get so ugly and so messy. By the time you get down to problems like this one, you're definitely going to want these fractions to go away. So I really encourage you to try to resist the urge to be like, no thanks, I don't want to learn something new. I'd rather just do it the old way, which would be to find a common denominator for everything, because you're not going to want to be rewriting these fractions over and over again. So try to stick with me with the method that I'm trying to show you, which will basically cancel out the denominators in all of your fractions. Okay. However, I am going to start by thinking about a common denominator. So like when I look at this first problem, in my denominators, I have a 3, an x, and a 5. So they don't have anything in common. I have no common factors here amongst all three of them. So my common denominator, and we weren't going to have to write this out every time, but if I were to make a common denominator, it would be made up of a 3 and a 5 and an x. We could call that a 15x if we really wanted to, but that's my common denominator. And so the way clearing the fractions work is I'm going to take this entire equation and multiply by that common denominator. I'm going to multiply by 3 times 5 times x, and I'm going to multiply over here by 3 times 5 times x. Now, let me be super clear about something. When I say that I'm multiplying by this thing, I don't mean I'm multiplying by that thing on top and bottom. So, like, let's say, for example, you don't have to write this down, that I ask you to do this. I ask you to do 8 times 3 over 4. That does not mean that you're doing 8 times 3 and 8 times 4. Because if you did that, you're just going to get an equivalent version of 3/4. This is really 8 times 1, and then you're going to multiply the 8 and the 3 together and say, okay, well, that's 24 over 4. And then you can cancel out the 4's here and say, okay, 24 over 4 is just 6. Okay. We're essentially going to do that same thing here. Okay. But when I say I'm multiplying by 3 times 5 times x, it's like this is over a 1. So my denominators are not changing because I'm just multiplying by a 1. I'm going to write out this first one super clearly. I probably won't do that for the rest of them. I'm going to kind of make this box over here like my scratch work. Okay. Um, I'm doing this 3 times 5 times x. You can think of it as being over 1 times 1 over 3. Now, if you remember when we worked with these fractions the other day and we were multiplying, if I saw a common factor, top and bottom, I could cancel them out. And then I really just have a 5x times this 1. So if I know this 3 and this 3 are going to cancel, then the math I'm doing here is just 5x times 1. Okay? And that's going to leave me with a 5x for this first term. Now, let's do the same thing with the 3 times 5 times x times the 4 over x. So I have 3 times 5 times x times 4, but then I'm dividing by x. So what that means is my x is going to cancel, right? This x is going to cancel with this x, and what I'll really have now for this term is 3 times 5 times 4, which is 60. And then let's do the same thing over here. I'm going to go 3 times 5 times x times 2, and then that'll be over 5. And when I do that, the 5's are going to cancel. So this 5 is going to cancel with this 5. And I'll have 2 times 3 times x left over. Really, there's a 1 here on the bottom, but we don't care about the 1's. And so 2 times 3 times x is 6x. And that equation, if you look at that equation that's written there in blue, is way nicer to solve. That's what clearing the fractions does, is it one by one clears out your denominators. And then you're left with something that doesn't even have x's or doesn't even have fractions in it. From here I would solve and I would subtract and I would say 60 equals x. And that is my final answer. And I want to talk quick about this final answer. And it didn't happen here. It might happen in one of our future problems. I hope that I threw one in here. But you can get something called extraneous solutions. And I don't know if you remember learning this term last year. But an extraneous solution is you do everything correctly. You do all your math steps right. And then when you find your value and plug it back in, it doesn't actually work in your equation. Okay. Um, and the thing that happens with these sometimes is you'll solve them and you'll get an answer that's one of your excluded values. So like here, if you think about this original problem, x equals 0 would have been an excluded value. Well, if I would have gone through all this work and solved and found that the only way to make it true was to make x equal 0, I have a problem. And so then I would cross my answer back out and I would say there's no solution because x is not allowed to equal 0. That didn't happen here, but we'll see if it happens in a future one. Okay, so let's look at our denominators here. We have a 2 and we have an x minus 3. And this is technically a denominator of 1. That probably means I don't really need to worry about it, although I do need to multiply on both sides. So I'm going to multiply both sides by a 2 and an x minus, or sorry, an x plus 3. Because that's what's going to clear this denominator or this denominator. And I'm going to do the same thing here. 2 times x plus 3. Okay, so when I do this first multiplication, this 2 and this 2 are going to cancel. And I'll be left with x plus 3 times x, which I'm going to write like this. X times x plus 3. Minus, now when I do this multiplication, the x plus 3's are going to cancel. And what I'll be left with is just a 2 times a 1. I'm doing this 2 times this 1. X plus 3's are gone. So this is just a minus 2. Over on this side, I don't have anything that's going to cancel because I don't have a denominator here. So I'm just going to put this all together and write this as 2x times x plus 3. Now, I do need to solve this all the way for x, and it may end up involving quadratic formula. I just realized that my calculator here at home might not have quadratic formula on it, so you may have to bear with me on that. But so let's go ahead and distribute here. Okay, so I'm going to get x squared plus 3x minus 2 equals, and then over on this side, I get 2x squared plus 6x. Okay, to be able to solve this thing, I need to move everything one way or the other. It really doesn't matter which way you go. I'm going to move everything to the left. So I'm going to subtract 2x squared and subtract 2x squared. I'm also going to subtract 6x and subtract 6x. Okay. So over here, this goes, and this whole side of the equation is just equal to 0. And then here I'll have a negative 1x squared minus 3x minus 2 equals 0. Okay. I might actually, you could use quadratic formula right here. I just want to be super clear. Like I was saying, the calculator I have here at home does not have quadratic formula on it. So I'm going to think about a different route I could go here. I'm going to factor this thing because I can usually factor when I'm not talking up a storm faster than I can even use quadratic formula. What I am going to do is, see how these are all negative? I'm going to kind of pretend that I like added these all to the other side. All right, I probably should have moved everything back this way instead, and then I would have had positive stuff, but that's okay. So this is now the equation I'm working with, x squared plus 3x plus 2. Okay, and then I'm going to factor and say this is x plus 2 and x plus 1. Because that's how I multiply the 2 and add to 3. And so my solutions are x equals negative 2 and x equals -1. Same thing you should have gotten if you used quadratic formula. Okay. And then check for extraneous solutions just means make sure neither one of these is an excluded value. -3 would be an excluded value, but I didn't get that as a solution, so I'm in the clear. These are good answers. Okay, let's try the next one. So this next one, if you do have things on the bottom that can factor, I would recommend doing it. So this 2x minus 6, I'm going to look at it and say this is really a 2 times x minus 3. And so then my denominator is going to need an x minus 3 and a 2. And this actually already has both of those. So that can just be my common denominator. I need 2 and I need x minus 3 to make everything the same. So I'm going to multiply everything by 2 times x minus 3. This might be a good time, by the way, to pause the video and see if you can work through this example and get the same answer I do. So 2 and x minus 3, I'll just keep going. So when I multiply, try to ignore this here for a second. This first fraction, my x minus 3s are going to cancel. This x minus 3 and this x minus 3 will cancel. So I'll be multiplying the 2 by the 4x, and that's going to leave me with an 8x minus, when I multiply this one, the whole thing is going to cancel, right? Because 2 times x minus 3 is the same thing as what I have on the bottom here, 2 times x minus 3. And so really all I'm left with there is a minus 5. Okay. And then on this side, my 2's are going to cancel. So 2 cancels here and here. But I'll be left with the 1 minus 6x times the x minus 3. Okay, I have to expand this and simplify to be able to solve. So I'm going to leave this side alone, 8x minus 5. I'm going to FOIL here, so let's see, 1 times x is x, 1 times -3 is -3, -6x times x is -6x squared, and -6x times -3 is plus 18x. Man, this is kind of a mess. Let's just see, 8x minus 5 equals, I'll put the -6x squared first. I have 18x plus 1x, so that's going to be 19x. And then a minus 3. I think this time, just for the sake of keeping my numbers positive, I'm going to move all 3 of these over to this side. So what I mean by that is I'm going to add 6x squared, and that means over here in this blank space, I'm going to add a 6x squared. I'm going to subtract 19x, which means under the 8, I'm going to subtract 19x. And then I'm going to add 3, which means under the minus 5, I'm going to add 3. So gone, gone, gone. And now this side of the equation looks like this. 6x squared plus 19x. And -5 plus 3 is -2. Yes, -2. Okay. Ooh, I don't know if factoring is going to save me this time. Let's see. 2s and 3s. I don't think I have a way that's going to make 19 in the middle there. So this might be one that can't factor. I don't think the way I have my camera set up, you're going to be able to see what I'm doing, but I'm going to take a look at Desmos. Again, quadratic formula, perfectly valid here. So I just don't have it available. So I'm graphing the 6x squared plus 19x minus 2. And I'm looking for my roots. And I am seeing roots. Yeah, these are decimals. That's why I couldn't find them with factoring. I am seeing roots at x equals -3.269 and at 0.102. And I should double check, but none of those should be excluded values because my excluded values are nice, happy whole numbers. Okay. So messy, but that is the correct answer. Okay, one more to go. With this bottom one, think about what our common denominator is. Again, this would be a good time to maybe pause the video and try this on your own. see how far you can get, and then let me catch up with you. For what my denominator needs to have, I need a 2x plus 1 and I need an x plus 5, right? And these two already have that in common. So I can just say I'm going to multiply by 2x plus 1 and x plus 5. And I'm doing that on the left and on the right. Okay. So when I multiply this first fraction, my 2x plus 1s are going to disappear. And so if you look at what's left there, I have a 4x on top with an x plus 5. So 4x times x plus 5 plus. Now, let's cancel this x plus 5 with this x plus 5. Sorry, I don't have a good way to cover this up. And what I'm left with is the 2x plus 1 over here and the x plus 3, which is on top there. So 2x plus 1 times x plus 3. And then over on the other side of the equals, I'm going to cancel out my 2x plus 1, so I'll have an x plus 1 and an x plus 5. No way around this. There's just a lot of FOIL happening here. Okay, and distributing. So here I'm going to end up with a 4x squared plus 20x. Here I'm going to end up with 2x times x is 2x squared. 2x times 3 is 6x. 1 times x is 1x, and then 1 times 3 is 3. And then FOIL over here, x times x is x squared plus 5x plus 1x plus 5. Okay, let's smash together everything on the left and everything on the right first, and then I'll worry about getting everything to one side. So 4x squared plus 2x squared, that's giving me 6x squared. 20x plus 6x plus 1x is 27x. And then I have a plus 3 equals, over here on this side, I have an x squared plus 6x plus 5. And I think I'm going to grab these things here on the right and slide them over this way. So I'm going to subtract x squared, and I'm going to subtract 6x, and I'm going to subtract 5. So minus x squared minus 6x minus 5. Okay. So what I have now, I guess I'll just kind of head over here. I have a 5x squared plus 21x minus 2. Okay, and let's see if I can get anywhere with factoring. 10. Yeah, I don't know that I can get anywhere with factoring here. Because my only options are 10 and 5, or 2 and 5, and then 10 and 1. So yep, I'm probably going to resort to Desmos again. You could do quadratic formula, okay, to solve this thing, because now this is equal to 0. I should have had my equal 0 in there. 5x squared plus 21x minus 2. Yep, messy roots again. Quadratic formula is your friend. So what you should be seeing with quadratic is x equals negative 4.293 and also x equals 0.093. Those are your roots. Okay, and that's all there is to this. All there is to this is canceling out your denominators. You're going to get some big long equation that usually involves FOIL, sometimes even multiple rounds of FOIL. You're going to get yourself to a quadratic, move all your stuff to one side so that you have a quadratic equals 0, and then quadratic formula is the way to go from here. So just to make a note to yourself that the way you would get to your answer from here is quadratic formula. This would be quadratic formula. This one I was able to do with factoring, but you could also do quadratic formula here. Okay. So you're going to give a few of those a try tonight. Tomorrow we will be reviewing for your quiz, and we'll touch base on anything that you feel like you're struggling with. All right. Have a great night.